Welcome to the course of compiler design. In the previous session, we discussed evaluation of L attributed definitions. Today, we are going to discuss the evaluation of S attributed definition. The syntax directed definition will give a high level of implementation details. That is, it will abstract the detailed implementation, and it is one of the notation used to attaching semantic rules to the productions. There are two types of syntax directed definition. The first one is S attributed definition and L attributed definition. In the case of S attributed definition, the particular SDT contains only synthesized attributes, and the semantic rules are placed at the rightmost end of the production. Also, the evaluation order is rightmost derivation in reverse order, or we can say that it is following bottom-up parsing. In the case of L attributed definition, we can use both synthesized and inherited attribute, but we are placing some restrictions. That is, the value of a particular attribute is evaluated from its parent or its left sibling only. The translation rules are placed anywhere in the particular production. That is, on the right hand side, we can place the semantic rules in anywhere. And the evaluation order is in order, or we can say that topological sort. So the evaluation translation schemes will provide the implementation details. That is, the SDT will give the abstract view, then it will give the detailed view. That means it will provide the evaluation order. The evaluation can be performed by either topological sort or top-down parsing or bottom-up parsing. Or we can say that topological sort means it is going to evaluate the tree or expression in order. That is used in L attributed definition. Then top-down parsing, we are following the leftmost derivation, that is used in only actions. That is, it contains only print statement or anything. It does not contain attributes, only actions. Then the last evaluation of the order is bottom-up parsing. In bottom-up parsing, we are following rightmost derivation in reverse order. This bottom-up parsing or rightmost derivation in reverse is used for the evaluation of S attributed definition. Consider an example for the evaluation of S attributed definition, or we can say that the S attributed definition as bottom-up evaluation. This is used in the bottom-up parsing also. That is, here we take the example as E produces E star T, then some more productions. To identify the left side and right side E, we are associating some numbers to the right non-terminal E and T. We have to find out the value of 4 minus 2 star 3 for this grammar. For that, we are first assigning some number to the semantic rules, as we have done in the L attributed definition evaluation. Then we will create the parse tree for the same expression. For that, we will use some derivation techniques. That is, E produces E1 star T, then we will replace E1 and T, then we will get the corresponding expressions. Then we will associate the semantic rules to these productions. The semantic rules associated with the production to the parse tree. Then we will get the annotated parse tree. You can see we are associate each and every semantic rules to the parse tree, so it will become annotated parse tree. In evaluation of S attributed definition following bottom-up parsing, that means rightmost derivation in reverse order. So we need the rightmost derivation in reverse. For that, we are going to first evaluate the rightmost derivation for this particular string 4 minus 2 star 3. To get the expression 4 minus 2 star 3, we are starting from the non-terminal e, then we will derive the rightmost or we will expand the rightmost non-terminal. That is, here only one non-terminal is e, we will replace that e by e star t. Then in that expression, that is e star t, the rightmost non-terminal is t, so we will expand it to f. So the expression will become e star f. Then the rightmost non-terminal is f, so we will replace that by the terminal, that is 3. Then the expression will become e star 3. Then the next the non-terminal to expand is the e only. Then we will replace e by t. Then the expression will become t star 3. Then we will expand the rightmost non-terminal t by using the production f minus t. Then the expression will become f minus t star 3. Then we will expand the rightmost non-terminal t. Then the expression will become f minus f star 3. Then we will assign the terminal 2 to the f. Then the only non-terminal in that particular expression is f. We will replace that f by 4. So we will get the expression 4 minus 2 star 3 by using rightmost derivation. To distinguish the each and every steps in the rightmost derivation, we are associating some number to it. We can see a number on the right hand side of each and every derivation steps. Also, we are going to associate this number to the annotated part string. You already assigned the semantic rules. In addition to that, we are associating the derivation steps, that is rightmost derivation steps, to the semantic rules in addition to the semantic rules. So the annotated part string also contains the semantic number. In addition to that, we are associating the number in the rightmost derivation. The first derivation is e produces e1 plus t. So the e is expanded here, so the number corresponding to e is 1. So we will associate that derivation step number 1 to e. Then the e star t is used in second here on the right hand side. So we will assign the same number to it. So we will get another part tree with the derivation order in it. Then we are going to find out the rightmost derivation. That is, first we will perform the step 1, then 2, then 3, then 4, then 5, then 6 and 7, then 8. On that order we are performing it. So the reverse of this rightmost derivation is the reverse of these numbers. That is, we will get the rightmost derivation in reverse order as 8, 7, 6, 5, 4, 3, 2 and 1. So in this order we are going to evaluate. That is, rightmost derivation in reverse. We get an order. In the same order we are going to evaluate the expression. So for that we will first evaluate the first derivation step, that is 8. You can see by it is indicated by an arrow on the rightmost derivation in reverse. So the 8 derivation is the value of 4 is assigned to the non-terminal f. That is the first step. The second derivation in the rightmost derivation in reverse is 7. So the next step is the value of 2 is assigned to f. the value of 2 is assigned to f. Then the next step is the 6. The next step is 6. So the value of 3 is assigned to the non-terminal f. Then the next step is 5. So the value is assigned here. We can see that the value of 2 is assigned here. Then the next step is the value of 2 is assigned to t. Then the next step is the value of 2 is assigned to e. Then the next step is the value is going to be calculated is the value of 3 is assigned to t. So in the case of last step, you will get the final result as 6. So in this way, the rightmost derivation in reverse is performed. First we are going to evaluate the rightmost derivation, then we will find out the rightmost derivation in reverse. On the same order, we are going to perform the semantic actions in the annotated parse tree. Then we will get the corresponding result. In the previous L attribute definition also, we will get 6 as the answer, because the given grammar is S attributed grammar. So all the S attributed grammar is L attributed grammar. So we will get the same answer in the both the case. That is, in the case of S attributed and L attributed, we will get the same answer. Okay, thank you.